Hello, everyone. Thank you very much for joining us today. We are excited to bring to you the 22nd webinar of Energy Evaluation Asia Pacific, where we are going to discuss appliance energy efficiency frameworks across Asia, focusing on evaluations of policies and impacts in China, India, and Indonesia. My name is Nazir. I'm your host for today's webinar and serving as a coordinator with Energy Evaluation Asia Pacific, which is a vibrant community of energy and evaluation professionals across the Asia Pacific region. Before going to the webinar, we would like to get to know you better. So please introduce yourself in the chat, sharing your name, your country, and the organization you're representing. We also have a quick icebreaker question. When you think of most energy-hungry appliance in your home, what comes to your mind first? Whether it's a refrigerator, an air conditioner, or any other. While you are doing that, I would like to share with you some quick housekeeping rules. First of all, this webinar is being recorded and it will be shared on our social media pages. And we assume that by attending and participating, you give your consent for this to happen. I would like to request you to keep your microphones muted when you are not speaking, but you can switch on your cameras for better engagement. Please use the chat box for questions. We have a dedicated Q&A session at the end, but the speakers will respond to some of the questions right after their presentations. They may also respond directly in the chat box. We'll be sharing with you a short feedback form at the end of the session. We will be happy to hear your feedback and suggestions for future sessions. As I shared, this session will be uploaded on our YouTube channel and on website. We will be sharing it through our LinkedIn page as well. And we will be sharing the session notes along with the slides through email as well as through the resource section of our website. This is the agenda for today's webinar. We'll start with discussion of the context and welcome remarks from Edward Wine, who is member of steering committee of Energy Evaluation Asia Pacific. Then we will have presentations from our three speakers, Hubo, Kinan, and Kishore, who are all representing CLASP. And we will have around 15 minutes of discussion and question and answer session at the end. Without further ado, let me hand it over to Edward Wine. Ed, over to you.
Hi there. Glad to be here. I'm going to share my screen and slides. So, here we go. So, welcome everyone to this webinar for Energy Evaluation Asia Pacific. EEAP is what we commonly refer to this organization. It's a nonprofit established in 2018, and it's modeled after two other conferences. The first one that I helped organize and work on was called IEPEC, the International Energy Program Evaluation Conference. And then we expanded to Europe in 2010, and it's IEPPEC, the Differences Policy and Program Evaluation Conference. And each of the conferences are held every 2 years, on the odd years for the US and the even years for Europe. And really, it's a community supporting the evaluation of energy policy and programs in Asia Pacific for EEAP. And our role is to take a leadership role in expanding the practice of and the capacity for objective evaluation in the energy efficiency and renewable energy program and policy arena. And we do this by developing resources and professional expertise to answer a number of different questions related to energy. Which actions pay off? How do energy programs and policies, how can they be improved? and what actions can be scaled up. Often there are these pilot programs, and then we want to expand it, either through all of Asia Pacific or at least through each of the certain countries. And so we want to foster the development of self-sustaining evaluation communities. So they run by themselves. They don't really need EEAP through workshops, conferences, webinars, and other web-based tools. There are four mechanisms we use and rely on. One is the collaborative approach. We collaborate with a lot of different stakeholders, including governments, non-government organizations, research institutions, and industry partners to drive the policy change. We also focus on data-driven decision-making. We underscore the importance of robust evaluation and data analysis to inform the policy decision makers as well as the policy decisions, providing recommendations based on evidence to ensure the energy policies are grounded in empirical research and best practices. And then, as I mentioned earlier, we conduct capacity building initiatives, and we do this through the workshops, knowledge sharing platforms, and I encourage everyone to go to our website, Energy Evaluation Asia Pacific website, and you can find it very easily these days. And then cases providing technical assistance programs to enhance the understanding and implementation of energy policy. And finally, we prioritize post-implementation monitoring and evaluation of energy policies. And by tracking the outcomes and impacts, we contribute to refining policies aligned with regional development and sustainability. Our structure is threefold. We have a steering committee, which I'm a member of. We have a coordinator, which is Nazir, and we have an advisory committee. And the steering committee in particular meets monthly to go over the different aspects I just mentioned to you. Again, why do we do this? We're focusing on both policy adoption and implementation. We're focusing on behavioral change, not just technologies, and then looking at the economic and environmental benefits. And we want to make sure that when evaluation is conducted, it looks at a lot of these issues. I'm not going to go into detail. You can see this later on the slide. As Nazir mentioned, we do have a number of different social media we use. There's, of course, our mailing, and I hope you're all on our mailing list. If not, just send an email to Asia Pacific at energyevaluation.org. We use LinkedIn a lot. Nazir and I use that often. And then we have our website and other aspects too. So today's webinar, I'm really pleased to see the title, the official title is Advancing Appliance Energy Efficiency Frameworks Across Asia, and then evaluating policies impacts in China, India, and Indonesia. We've had previous webinars where one or more speakers may talk about appliance efficiency, but this is the first time where we have all three presenters talking about appliance efficiency. The other noteworthy fact for this webinar is they all are members of CLASP, and you'll hear more about who CLASP is and what CLASP does. I've been fortunate to know CLASP since day one when it was formed, and a number of the key people involved in CLASP, and they've had great leadership over the years. And it's really, I admire CLASP for many reasons. One is they've been able to expand to different regions in the world. So not just the US or European, but really covers the whole world. And you'll hear more about some of those activities. And the other thing is, in terms of big countries, China, India, and Indonesia, it's hard to get bigger than those countries. So we're going to learn a lot about what they've been doing in the countries under different cultural conditions and seeing how successful they are. So without further ado, we're going to introduce Hu Bo from China, and he's going to talk about his country's mandatory appliance policies and their impact assessment. I should mention one other thing before he takes over. Each speaker will have 15 minutes, but with Hu Bo, Usually we hold questions to the end of the webinar, but he's actually at a conference as well. So we'll have him present, and then at the end, we'll have time for him for people to ask questions. And then if there are more questions about his presentation later, at the end of the webinar and he's not there, his colleagues will hopefully try to answer those questions. And if not, we can also use the chat function and you can put your questions starting now for each of the presenters. So without further ado, Hubo, I'm going to stop sharing here, and then you can start sharing your slides, and we'll go from there.
Thank you, Ed. I'm going to start share my screen now. Okay, so good morning, everyone. I'm Kubo from class. I cannot speak louder because I'm in a big hall of the middle of the conference. So I'm going to present something about China's monetary appliance policies and, of course, the impact assessment with our tool MAPC. Why appliance is important? Because as you can see, that appliances account for about 38% of China's total emission. The total emission in 2023 is about 12.6 gigatons. That means it's around 4.7, 4.8 gigatons of appliance emissions. So within the appliance emissions, we have the three big consumers, which are motor, cooling, and lighting. So that means the appliance efficiency has vital significance for China's carbon neutral goal in 2060. How we can, regulate appliances by maps. That's what class is working. And China right now has about 6, 7 maps until August 2025 in effect. So the future trend that the numbers of the standard is going to be reduced will be integrated because take the commercial refrigeration, for example, previously we have 3 or 4 maps, but now they integrate them into one map. That means the numbers of the maps in China are going down, but the product scope will expand it because it will be regulated by the maps. And from the right-hand side, you can see that the cooling, motor, and the lighting takes almost half of the numbers of maps. Of course, not the importance, but the numbers of maps. And we have China maps and also have the grading systems. Each maps establish either 3 or 5 grades. Normally grade 3 or grade 5 will be the maps, but grade 2 or grade 1 means the BAT, best available technologies. That means high performance product on the market. I think that's China map system, not only for maps, but also for the grading system and also establish the foundation for China's energy label program. So why assessment is important? Because there are gaps between national tools and other global tools. That's why class is going to develop some new models with our MEPC because the up-to-date, I don't want to repeat this again because we want to consider about usability, flexibility, transparency, integration, authority to make a model usable and also produce credible results. And there is tools available right now. I don't say on market and in our society. And the class developed MAPC. We have the PAMS, Excel, the bonus, and also PPAT. I know that the Indian team, the class of Indian team use PPAT as a tool to provide policy recommendation for the Indian government. And also we have there are other comparisons, especially for U4E and also for GCI. And also I know that previously the LBL's LEAP model become took the lead for a long time. That's a tool available, and we decided to develop a new one. I will skip this one because that's a process how we can do make our impact by modeling to affect the policies. The methodologies of MAPS is pretty similar with PMS because we model the sales over a lifetime. We multiply the energy stock with energy consumption. Finally, we get result of the energy consumption and also the CO2 emissions. And also we use up-to-date data sales from market and also some other integrated from IEA, from UNDP, from UNEP, and also World Bank. And also we have country-specific data and especially to validate the findings because MAPS will have the global map website. And also we use MAPS with our primary research in some countries, but countries like China or maybe in the EU, we have the validated result because based on the latest progress, because MAPS global just only screenshot for some year, but for the up to date, I will show you how we can do to evaluate the impacts and also to project the potential for the future with 2 cases later on. And we did the validation of our results. And from the left-hand side is country-specific. You can see that it's more or less aligned with a line. And from right-hand side, we compare the results with different also countries with maps the BAU result with India, China, Brazil, and also Mexico to estimate the BAU estimate. We found that the MAPSI tools has similar or more or less credible result with the rest of the other models. And the baseline for our assessment. So for the appliances, it has life cycle. Its viable curve is a very good theory to anticipate the lifetime survival rate of the appliances for 1 year. From the first year is 100%. Along with the time, with age, the appliance will face down until maybe the 30 years. That depends on the lifetime design of the appliances, but that's the basis of our CLASP's model. This detailed provide on the left-hand side. I want to repeat again. And with for the air conditioner sales in 2020 is 5 million, and along with the time in 2021, 2022 until the survival rate, the survived appliances on the market will go down. That's for the air conditioner sales in 2020, and then for 2021 it was follow similar life cycle quest survival rate, and then but the numbers of the sales will change along the time because 2021 be higher, 2022 even higher, and then with the vertical, if we sum the vertical of each year survival, then that's a stock of the product on the same year. Then we have the result of the stock. With the stock, we can calculate the energy because energy is stock multiplied by the average unit energy consumption we call UEC. UEC is a typical consumption of one appliances in which year. Then we have CO2 emission with stock multiply average at UEC. That means power consumption multiplied by the emission factor. We get the CO2 emissions, and also we have the electricity cost. Of course, in different countries have different other considerations for the space water heating. We have different fuel sources, maybe with fossil fuel, gas, or even the coal. For the lightings, many different scenarios among different technologies. But basically, we follow this in the stock. With UEC, we have the energy. With energy, with emission factor, we have the CO2 emission. Based on different scenario of UEC, when we have the difference of the energy consumption and emissions, the difference is emission reduction potential or emission reduction and also energy saving. Then we get that's a basic theory. And let me, the most important is how to apply these tools in life. The first one, we use the MAPSI to evaluate China IAC maps impact until 2030, because the new maps, China maps, GB 21455 2019 is one of the world leading maps since 2020, as the figure shows that class the world's best maps. We found that China already has 5.1, the world leading of the cooling only appliances around the world. And this is market impact of this maps. It stimulates very rapid market trends in 1 year. We phase out the fixed speed air conditioner from the market in 1 year. Now the fixed speed air conditioner on China only 3%, and the right hand side is the benchmarking of 2 maps. It's already it is published document in our report. You can download this from the report. Then the market impact in that it's huge. Since 2020, we have to evaluate impact of this maps implementation. First one, we need the stock or the sales. This is China RS markets, keep rapid increasing since 2010. And then we thought maybe in 2017, 28, it's reached saturation, and until 2030, I think it will, approach the already saturation based on this stock and based on sales. We used MAPSI to model the sales, the stock. Finally, we found that the market, the stock will reach about 800 million in 2030, because this is only for the impacts for 2030. That means that's a start curve with our MAPC methodology. And this is the Chinese part, the REC product map. We found that the average, we have the 1 HP, 1.5 HP, 2 HP, 3 HP, the shares structure. Then we have typical the cooling capacity. Then when we said that 3,900 watt is the weighted average of the cooling capacity, based on this cooling capacity and the APF, we define two scenarios, two impact scenarios, and also with BAU, and also with different scenarios. Then when we have different APF, then we calculate the UEC. With the UEC and also stock, we got the energy consumption and also the emission, and also we finally get energy saving and emission reduction. It's automatic calculated by the tool with our MAPC. And that is the data we have, and this is result. Based on this analysis, we can see that. Okay. So this is the emission reduction curve of this three scenario, and that's reduction. It's emission, not emission reduction. Emission different scenarios. Finally, based on the cumulative, we found that under this map scenario, the cumulative savings between 2020 to 2030 will reach at least 700 terawatt hours, and also cumulative emission reduction could reach almost 400 megatons CO2. But based on the best grade 1 scenario, the saving will be high to 1,500 terawatt hours. Emission reduction cumulative can reach about 700, almost 800 megatons of CO2. That's the MAPS impact and also the BAT impact. And this is the work we evaluate the impact of the existing maps. But now China, we are going to work with CINIS to revise the RS maps again. Then we need to project the policy impact or the technical potential in next years until 2060. Then we did this again, but the market changed because we found that the China market in China in 2022 returned to growth. It breaks through the 100 million units a year in 2023. In 2024, I believe this year we have similar numbers. That means the total sales of China, return to growth. I think that's something unexpected. Then they'll have to redefine our, the projection model until 2060, and then we set different scenarios, based on the grade rate. It's APF4. We have the UEC weighted. We believe the structure of the product is similar. And the UEC, we have the new grade 3, which is APF5. That means reduced to 700 kilowatt hour. And then based on research with university, we found the best one is 6.25. That means the annual energy consumption can be reduced to less than 600 kilowatt hours. But it's based on cooling and heating, because China would almost air condition, China market come to both cooling and heating. And with this new market scenario, we project that China, the total stock will go up until 2040, reach a saturation rate. It will reach 1.2 billion units until 2040. And then it will keep stable until 2060. And then based on this stock and also the UEC we used before, we got some new results. This is yearly annual emission reduction. From left-hand side, we can see the curve. That's emission reduction. We can see that the emission reduction will increase until 2040. Then the reduction will go down until 2060. Why? Because emission factor plays pretty important role since 2040. Because from the right-hand side, you can see that the emission factor of China keeps decreasing. The final ultimate goal in 2060 is 150 grams per kilowatt hour. Then that means we have to work or increase the maps as early as possible to explore or get result of the best maps. I think that's a curve of the emission factors impact. And finally, we get from different scenario. If we increase maps to APF5, we have this blue line, that's cumulative reduction. If this APF richly 6.25. We'll have the orange one. That means, of course, big numbers. I don't want to repeat again. You can read from this map. And I think lastly, I think that's that's the tool we use, and also we make in our cases, and also we use those data to work with policymaker. And I think this presentation cannot be presented, can shared online right now because some of the data still is internal reporting. We're going to publish results maybe later this year or earlier next year. Then we can publish this slide because a lot of data, a lot of analysis still within internal discussion. Okay, I think that's all from my side.
Thank you very much. That was great and on time. As I mentioned at the outset, if people who are listening to this webinar, if you have questions, this is the time to ask Bohu because he will disappear in a few
Because
minutes
yeah,
because he's attending a conference. And
because
we're fortunate
I'm
he was
going to.
able to speak while he is at the conference. So I appreciate your taking the time out for that. But um, does anyone have questions? You can ask them in the chat function at the bottom of your screen in Zoom. And also, if you can continue to ask him questions and we can address them by the other two presenters at the end of this webinar. But I don't see any questions right now. Um, so it was really good. The numbers themselves are very impressive. Uh, 800 million room air conditioners. Nowhere else can we find that.
And we did this
Whatever
3 years
impact,
ago.
even if it's marginal, it's a huge impact. So
Yeah,
it's
we did
really,
this 3 years ago as 800 million, but now we increase it to 12. Yeah,
uh,
1.2 billion.
oh,
That's
wow.
even our expectation because
And
now annually, yeah,
tomorrow it'll even be more, right? Almost
yeah,
every day you
yeah,
get more
yeah,
information. So
yeah,
yeah,
yeah.
that's great.
Because we have
Well,
to validate and update the figures,
yeah.
with real change because projection can be changed with real market development.
Well, what do you just, I'll ask a question. What's, of all the data that you collect for looking, evaluating the impact of these, in this case, the room air conditioners, what is
You
the,
know, we
what
mhm.
has the most uncertainty for you? Where's the greatest uncertainty?
I think for air conditioning, that's a good case because for uncertainty is that for the you if like the UEC for example, we have the data from the energy label. I mean, for the energy from China energy label, it shows the typical energy consumption for which performance, which capacity. Then we can easily get credit result of UEC. That's a good first one. Second, we have the market results from different market research company and also the national state disclose this kind of penetration rate of China's total penetration rate. In 2024, the penetration of China reached about 1.5 RAC per household. That means
Okay.
it validates our, the model because
Right.
model is based in bottom up.
Yeah.
And then we
Yeah.
validate the total stock with this model. Then that gives us confidence from our modeling is okay. At least we can't say it's perfect, but it's okay.
Yeah. Okay. Very good. Thank you. I think we'll go on to our next presenter and you
Okay,
can
I'm
stop
leaving.
sharing your screen
Bye.
and then we'll go to Keenan Putra. Again, he's from Indonesia and he'll talk about evaluating policy impacts, Indonesia's experience in energy efficient appliances. And you can start sharing your screen as, yep, that looks good. And you can start your show. Very good. We all see it, and I'll let you proceed.
All right. Thank you very much, Ed and Nazir, again for hosting this webinar session. And good morning, good afternoon, good evening to all of you. My name is Kinan. I'm from CLASP, the Indonesian team, and today I'll share to you briefly hopefully I can do it under 15 minutes about Indonesia's experience regarding energy efficient appliances. So I think I give some context on how CLASP is supporting, like Ed mentioned early beginning, that he was impressed that CLASP is able to grow and do the work not just in the US or Europe, but also towards the East Asia and also countries with big economies. We try to identify each year, we try to evaluate on what countries have like the most emission from appliances in each country. So we iterate this every year and we try to rank them. And this is how we try to prioritize our work in trying to support that countries in order to have better efficient appliance policies. So within the top 20 countries that we have identified, Indonesia is actually ranked number 7. Obviously, China, India, US, the big economies have the highest efficiency appliance potential on emission reduction, but Indonesia is also within the top 10 countries. So that's how CLASP started supporting Indonesia towards its appliance efficiency. And just to give a bit of context regarding Indonesia's energy demand landscape, we can see that actually the residential sector is the third largest energy consumption after the industrial sector and also like the transportation sector. So and electricity is the third largest fuel type after fossil fuel and natural gas, which is most commonly used. And the impact of like this enhanced NDC, like the commitment of Indonesia's government towards emission reduction by 2030. We have 5 sectors. So there's energy, there's waste, there's also forestry. Energy is one of the largest sector that has contribution towards the emission reduction or like the goal. And energy efficiency within the energy sector is one of the 5 main strategies, which has a big contribution, like 38% of the 5 strategy comes from energy efficiency that will support in achieving the energy sector's commitment of up until almost 360 million tons of CO2 equivalent by 2030. And within the energy efficiency stream, it is mentioned that actually the increasing the efficiency of electrical appliances, this plays quite a big role in trying to achieve this goal. So 23% of the contribution within the energy sector actually comes from appliance efficiency. So this is actually stated within the enhanced NDC document. So this is a commitment from the Indonesian government. So appliance efficiency has a big role in trying to reach climate targets from Indonesia. And I think it's worth note to mention that Indonesia's journey in terms of appliance efficiency is relatively young, especially when you compare it to the appliance policy in India or in China, where it has been running for 20 or maybe 30 years. In Indonesia, it only started roughly around 10 years ago. So back in 2010, the Ministry of Energy established a new Director General for new renewable and also energy conservation. And this is in 2010, the institution has been established. And by 2011, it's the first appliance standard for efficiency regulation. So at that time, it was for lighting products. And then in 2014, it's the first energy labeling for the appliance efficiency, also for lighting products. And then in 2015, we started to implement both the mandatory standards and also the energy labeling. So that took quite some time, and it's established for lighting products and also room air conditioner in 2015. And then starting from 2021, they established like a new umbrella regulation for the whole energy conservation activities. So that includes energy efficiency, energy management, energy audit. So all the maps and all the energy labeling regulation is under this regulation umbrella in 2021. And since then, they started to speed up the efforts of appliance efficiency, where there's 4 new appliances for refrigerators, fans, rice cookers, LEDs, also a revision of the AC maps, and also From 2023 up until now, they also have added 2 new appliances for showcase beverage coolers and also televisions. And this year, earlier this year, we have already passed for water dispenser, and also towards the end of the year, they are finalizing the regulation for water pumps as well. So 10 years is still relatively a young program compared to other economies in the world. And clasp journey or like support in Indonesia starts in 2018. I think this is when we started to identify and try to support the government on how to increase the ambition or like the stringency of appliance efficiency policies. And we started with a residential end use survey back in 2018. And then we helped develop the all the appliances that was mentioned previously. But I think what's important to note or like to mention is that we conducted a residential end use survey because we identified that actually the residential sector was one of the highest emitting sectors compared to like the industry and commercial, but in terms of like the number of potential of emission reduction, not just that it's important, but it's more approachable than making a new program, but starting with the industrial sector, dealing with industries and manufacturers. So we started with the household sectors in terms of the potential emission reduction, and we did that conducting a number of surveys, a number of market studies to have a good sense of baseline data. And we did a residential end use survey back in 2018. So across Indonesia, we conduct a survey, almost like 6,000 households, to provide the energy consumption baseline to inform future policies. The goal of this survey was to identify what appliances is the most used within a household in Indonesia. So we covered all different types of household, from the rural areas into like the big cities, and also we tried to conduct the survey in all the different grid connections of the household to the main grid. So we try to cover all of this and have a good representation of the households in Indonesia. And we managed to identify the top 10 most consuming appliances within a household. I think what's interesting in here is that from the study that we actually found out that maybe this study, the result of the study wouldn't have been the same if it was being done in like say Europe or like in the US, because actually the number one most consuming appliances is actually rice cookers. I think this really reflects the the cultural context of the Indonesian market, and also like the region, that we eat rice every day for our meals. So like maybe sometimes in the morning for breakfast, but of course like for lunch and for dinner. If we haven't eaten rice, we don't say we have had a meal. So rice cooker is actually the number one most consuming appliances, and then followed up by refrigerators, sliding, TVs. So this is what we propose and we recommend it to our partners in MEMR to, if we want to set up regulations for appliance efficiency, let's start with the most highest consuming first. So we start from rice cookers, refrigerators, sliding, TVs, and so on. And from this study as well, we try to gather on the insight from the household regarding the awareness of the energy efficiency, and the response is that the three main factors of people at the time, so this was like in 2019, and trying to buy new appliances was based on, first it was the price, so affordability factor, and then the second point is that they were considering the name of the brand. So if it's a huge brand or like a well-known brand that is common in the market, then that's a main consideration factor. And the last one is the energy saving. So it actually comes into a play in their decision making. But at the time, in 2019, so there was only two regulations. Only 6.5% of the household sector that the people were aware about this energy labeling. So because the program is still young and still new, it's not something that's already common within the Indonesian market yet. I think this would be different for the case of like maybe in India or China or Europe, where energy labeling has already been there for a number of years, and people might use that or like take that as consideration for them in making decisions to buy appliances. So this is just a brief overview of the program structure for the maps and labeling process. I'll just try to go quickly, but the coordinating ministry is from MEMR, the Ministry of Energy, under the Directorate of Energy Conservation. So the process is that the brands usually request for energy efficient certificate when they try to sell a new model in the market, and then the product certification body will conduct lab testing with a lab testing partner that is already appointed, and then the results will be passed back, and then the certificate will be issued to the importers or the manufacturers, and then both the product certification body and also the importers or like the manufacturers, they have to submit reporting of the result of the lab testing and also the results of the energy efficiency certificate to the MEMR. And I'll share with you a case study for room air conditioning MEPS policy on like how they approach in trying to establish new regulations, or how they evaluate the existing regulation, whether it's already time to increase the standards. But in general, the ideal case is that after 2 or 3 years that the policy has been established, they start to conduct a review of the existing regulation, looking into like the market conditions and also like the product registry that has been registered. They start to evaluate if the current existing policy needs to be revised. In the case for ACs, I think the experience has gone through like three different revision states. So it started in 2015. It started with the EER metric, and then in 2021, it started its first revision. This was also changing the metric from EER to a CSPF, which was advocated by the ASEAN Center of Energy to have like a more harmonized metric for appliance efficiency using the same metric, so then it'll be more easier to compare within the region. And then in 2023, it's the third revision for the AC policy, which is phasing out the star 1 for the map. So now the maps is at star 2. So I think from 2021, when it's already within the CSPF metric, CLASP had published a study on Southeast Asia dumping study report on air conditioners. So this is a study that was conducted early in the year to showcase the effects of like manufacturers, importer, continuing to export or sell obsolete products that they cannot sell in their own market. They continue to export or sell into other markets with lower MEPs. So this is the case most often found in developing countries. This is what we found out was like the sales of inefficient air conditioner within the Southeast Asia region. Actually, most of it is imported within the ASEAN region, but also imports from outside of the Southeast Asia region. So 74% of the total sales were sold within the market of inefficient ACs, and 71% of this inefficient ACs were actually manufactured and produced within the Southeast Asia region. So this is being imported intra-ASEAN. So let's say like ACs that is being manufactured in Thailand or Vietnam, when they cannot sell these products in their own economy or like in their own country, they sell it to Indonesia, which at the time might have lower MEPs. So this is the range of AC efficiency by the market. I think what we showed in here is that we need to increase our MEPs so that we don't have MEPs lower than other economies within the region, just so we prevent these dumping of inefficient products. And that's when in 2023, the revision was finalized through market condition review, public consultation, and this additional study of the dumping study helped the ministry to have confidence in trying to revise the MEPS to increase the standards. And again, like in 2023 now, we try to revise the current existing policies, because after Indonesia revised the policy in 2023, several neighboring countries also started to revise their policy to higher efficiency again in 2026, 2024. And this, similar to the previous round, in order to prevent the dumping, like Indonesia aims to review the current policy in 2026 with the goal of finalizing this in 2027 to, again, prevent the dumping and also increase the appliance efficiency. And there are several challenges in trying to increase the MEPS policy because of the business environment of the, let's say, the AC environment. Key stakeholder partners have a widespread perception that inverter technologies are less effective in operation for Indonesia due to a number of factors. This could be like the operational habits, leaky construction, lack of compatibility within the climate condition, and also the vulnerability of the main grid in Indonesia. So in trying to answer those questions, we conducted another study. So the last time we did a dumping study, but this time we tried to do a comparative testing of inverter technologies and also fixed speed AC. So this is again to help us answer some of the doubts and questions from key stakeholders. And hopefully from the result of the study, we can answer these perceived incompatibility, and we can gain stakeholder confidence from the ministry for them to revise the current efficiency policy. So I think this just shows that for each appliances, the approach would be similar, that we try to review what is the existing MEPS policy within the ASEAN region, and also we try to see the most dominant importing countries from outside the region. We try to have the same MEPS or not higher from those regions. And in trying to increase those MEPS, we try to also answer some of the pushbacks, or like the challenges from like the manufacturers, from the business environments, through numbers of study. This depends on each appliances again. So that was the case for ACs, but it could be different for other appliances. And I think lastly, these are the number of challenges and also opportunities. I think for appliance efficiency, the challenges mostly is in Indonesia, the electricity price is heavily subsidized. So low electricity price makes people have less of concern on their energy bills, like monthly energy bills. And also the readiness and competitiveness of the local manufacturing industry in Indonesia itself is also a big challenge in trying to increase the policy, because the ministry tries to always protect the local industry throughout the map. So they don't want to set the maps too high until like the local industry cannot manage to meet those targets. So this is also one of a challenge, but also an opportunity for us to support this local industry. And also, I think regarding the readiness and also capability of the lab testing infrastructure, this is also one of the key challenges in trying to establish better maps, or like with better scope regulation, and also
Right.
yeah. And yeah, I think in general, that's what Indonesia's experience has been for appliance efficiency.
Thank you.
Yeah.
Yeah, that was very good. We'll have time for questions at the end, but I have to ask one right away. Is
Sure.
there outside of, does Indonesia look at one particular country as a reference point? And if so, which one is that?
Yeah, as I mentioned, like we try to benchmark within the ASEAN region first, because we like within the ASEAN region, there has a lot of like strong industry manufacturers for appliances as well. And usually these are the ones that is being traded or like exported or imported within the region. So from the AC, actually 70% was actually traded within ASEAN. So we try to benchmark ourselves to the standards established within the ASEAN region. So first, we try to make sure that we prevent the dumping within the ASEAN region, and then secondly, we
Right.
look into other countries, let's say like China, because they have a strong industry capability and they export a lot of these appliances to Indonesia as well. So we try to benchmark to them as well,
Yeah.
in order
Okay.
to again like prevent the dumping.
Good. Thank you. A very interesting presentation. And we'll go to our third and last presentation, Kishore. He's from India, and he'll talk about transforming India's appliance efficiency landscape to achieve climate goals. So we'll have him start sharing his screen and slides. That looks good. I can see it. Please proceed.
Thanks, thanks, Ed, and thank you for giving this opportunity to present. Hi, everyone. This is Kishore from Clasp India office. We are based in New Delhi. I work as a senior manager here. So, as Ed said, like today, I'll be covering about transforming India's appliance efficiency landscape to achieve climate goals. Yeah, I'll try to cover as soon as possible. Yes, yes. So before starting to my presentation, just want a quick overview about what CLASP does and our mission as well. So we work on improving energy and environment aspects of appliances that we use in day-to-day life, which also helps to accelerate our transition towards more sustainable world. In terms of where we work, we have a head office in Washington, D.C. in USA, and we have a regional offices in all other continents. And we have regional office in Brazil, in South America, and in EU, we have office in Belgium. In Africa, we have regional office in Kenya, Nairobi, and in Asia, we have offices in New Delhi, Beijing, China, and Jakarta. And we have two portfolios. One is climate and another is clean energy access. For example, in India, we work on both portfolios as well. So this is about our organizational presence across the globe. Coming to CLASP India, so we work closely with Government of India called Bureau of Energy Efficiency, where they are the nodal energy agency for the country, and there is a program for appliances called Standard Labeling Program, and we've been providing the technical support to them for the last 20 years. And if you talk about the kind of support, they're majorly distributed in 6 buckets or 6 areas, I should say it. One is on the appliance energy efficiency, other is on the compliance, market transformation, and roadmap for doubling the rate of energy efficiency improvement, which was committed in G20 in 2023. And also we support on the digitalization and also at the subnational effort. Subnational effort has been the recent diversification that we are working for the market transformation, also support with the government in the subnational effort. Apart from all these areas, we've been also very much focused to meet Government of India priorities and also ambition for the standard labeling program. As they have committed by 2030, they want to increase the appliance coverage from currently 41 to 50 appliances. That's been the commitment based on the other international goals and also, the own priorities of the country, I should say. And at the same time, in the class, we are focusing on 10 major appliances, potent appliances, which are energy intensive in nature, which are also part of our strategy. Those appliances are air conditioner, refrigerator, LED lighting, fans, heat pump, cooking, induction hob, color television, motors, and solar pumps. So these are all used in different cooling, heating, and cooking and lighting applications. And we assess like globally, they are mostly widely used across other countries as well. Yeah, so that's about our work in India. Talking about in terms of economy and also in terms of the climate goal, like currently where does India stands and where actually they're planning to go ahead in next couple of years. So first I want to focus on the economy side. As you all know, India has been growing very fast in terms of the economy. They're currently the 4th largest economy. And at the same time, we are like third largest energy consumer as well, because of our requirement of energy needs in all different sectors. But when you talk about the per capita, we are currently third of world average. We still consume less energy compared to other developed countries or developing countries. When it comes to the manufacturing ambition, India currently is focused to promote more local manufacturing and to boost it. They're trying to promote different schemes and policy reforms, like providing incentives to the local manufacturing as well. And at the same time, they're also focused on improving appliance energy efficiency, which are locally produced or not imported, and they're focused more even on the export market as well in the manufacturing sector. If you talk about in terms of the climate goals and also the energy goals, by 2030, they want to meet the Paris Agreement NDC target, which was committed, and also they committed to doubling the rate of energy efficiency. They're plan to meet those goals. And at the same time, India plans to become a developed nation, a Vikasit Bharat, by 2047. And they're bringing so many policy reforms across different sectors, length and breadth of a country, to ensure they meet those developed nation. And at the same time, they're also want to focus on the climate aspect to become a net zero by 2070. Of course, they want to even achieve early as well, because the kind of ambition they're carrying, it's been tremendous, and we all can witness that in different achievements that they share in the public domain. And talking about the appliances, I think appliances been a central part of all these commitments, I should say it, because if you talk about the in terms of the impacts and energy savings in 2023 and 2024, there has been a monetary savings for the consumers close to 15,000 million US dollars. That's a big amount. That's consumer getting benefited of these energy efficient appliances. And also in terms of the CO2 emission reduction, they contribute to 65% of the total CO2 emission reduction in 23-24. So as I said, like appliance plays a crucial role in all these ambitions. And moving on in terms of where does appliance stands in terms of the annual energy consumption, just to give a big overview. So in India in 2016 and 17, if you see in this graph, India used to consume annually close to 1,000 billion units of electricity every year. But if you see currently in 23 and 24, the energy consumption actually almost like 50% increase. So India consumed approximately 15 billion units of electricity in 23-24, and majority goes to the industrial sector with a 42%, followed by the residential sector, which is 24%. And also the interesting fact is for the residential sector, there's a projection that this is annually going to increase 6% every year. Apart from these two sectors, the other sectors like commercial, agriculture, and the railway sectors, they are also keep on increasing year-on-year basis. Coming to in terms of the appliance energy efficiency and India standard labeling program, I just want a quick overview and the journey of the program since the inception to till date. So the standard labeling program actually came from the Energy Conservation Act. So this act actually came into force from 2001, and subsequently in 2002 the Bureau of Energy Efficiency got established. But the standard labeling program got developed, and they launched the first voluntary appliances program in 2006 with air conditioner refrigerators. But since then the program has been growing exponentially. As you see in 2007 to 10, there has been total 12 voluntary appliances covered in that 4 years of time span. And in 2010, they made 4 appliances mandatory. Yeah, I think that's been one of the game changer decision in terms of the policy reforms. Since the mandatory policy came into force, I think the whole market shifted towards more efficient appliances. In 2011 and 20, in that 10 years of span, they totally covered 26 appliances, and 10 of them are mandatory and 16 of them are voluntary. And if you see in the last 2 to 3 years, their numbers has been again further increased because they've been so much focused on the cooling appliances because of India cooling action plan and the commitments. So I think if you see currently the total appliance coverage is 41 appliances, and 17 of them are mandatory and 24 are voluntary. And at the same time, as I said, like Bureau of Energy Efficiency have an ambition to coverage appliance to 50, but at the same time they're planning to make 9 more appliances mandatory from 26 and 27 onwards, which are in the part of voluntary to mandatory transition, I should say. Yeah, just to ensure the impact and the energy efficiency progress expedited. Yeah. Coming to in terms of the key stakeholders, as I said, Bureau of Energy Efficiency is one of the implementing partner, but at the same time, it's also crucial to collaborate with other private and the public sector. So one of the key stakeholder is Bureau of Indian Standards, who makes us the standards, which are like a heart of the overall energy efficiency policy, basically defines the energy efficiency procedures, test procedures, and also the baseline efficiency values in the test standard. Those considered as a reference for developing the energy efficiency norms for the standard labeling program. And the other important and crucial stakeholder is industries. Yeah, and they are like closely 3,500 manufacturers who actually adapt this efficiency policy and implement it and ensure those are produced as per the energy efficiency norms. And there are other important stakeholders like test facilities, which are used to test the efficiency of the appliances before going for registration or being even before coming into the market. And at the same time, there is another important stakeholder called state designated agencies. There are 36 state designated agencies for every state in our country. They have a government department and they work on supporting on implementing the energy efficiency norms, and even for the standard labeling program, the state designated agency do work on implementation aspect as well. Yeah. Moving on, as I said, in terms of the appliance coverage, they're totally 41, but 17 are mandatory and 24 are voluntary. This is all the list of appliances. One of the interesting aspect of the overall program is that there are two energy efficient labels used in this country. One is called comparative label, another is called endorsement label. But so far, the consumer do understand very well only the comparative label, because as you see on the screen on the right hand side, there is a sample label which actually has different stars 1 to 5, where 1 is least efficient and 5 is the most efficient. And it also talks about the efficiency of the appliances and also different technical aspects. So consumer understand this label very well compared to the endorsement label. And because of that, out of these 41 appliances, 39 appliances have comparative labeling only, other 2 has an endorsement label. Yeah. Moving on in terms of what's been the success of the program since the launch, and how many appliances has been made energy efficient. So for that question, the answer is, so far there has been a 4.3 billion appliance has been star labeled or been energy efficient since inception to till date. As you see, when the program got started in 2007 and 8, that there were only 39 million appliances were produced under the SNL program. But if you see in 23-24, the overall star labeled appliances, energy efficient appliances, are close to 549 million. And that's been the kind of a transformation. It almost like increased by 15 times since inception to 23-24. And the interesting aspect is that they totally registered by close to 3,500 manufacturers for all different appliances categories, and the 28,000 models. Yeah, and I think we anticipate these numbers keep on increasing because the appliance demand in the country for different applications is increasing, and also because we are developing economy, there is more demand for the all kind of appliances in our country. Yeah. Moving on, what's been the efficiency improvement? Because though there are some policies, India has been very uniquely placed in terms of the efficiency improvement, and the story has been very satisfying to see it also, because once the policy have an efficiency, but over the period that efficiency need to improve and the reforms need to come in, because the technology keep on changing every time, and there is always a need for the innovation and R&D. So I think the India stands as a best case scenario to showcase like what has been efficiency improvement. And if you see under mandatory appliances, this is all the mandatory appliances where efficiency has been increased for every 3 years. The minimum energy performance standard, the MAPS, which is also 1 star. And the highest efficiency improvement you can see in the refrigerators with 67%, and further efficiency improvement also done in the color television and electric geysers and room air conditioners, LED lamps and ceiling fans and transformers in the washing machine. One of the interesting aspect is that in the last couple of years, there has been so much of a trend in India to check what is being the efficiency improvement and where they stand globally. So I think we are very proud to say that I think for the refrigerators and LED lamps and air conditioners and the ceiling fans, these all appliances are like globally par with energy efficiency, and some of them are even global best maps also, I should say. Yeah. So that's about the efficiency improvement maps. Coming to in terms of the impacts of the program, I think this is again one of the transformational success, I should say. Since inception to till date, there has been an electricity saving close to 691 billion units of electricity overall in the last 19 years, and the equivalent CO2 emission reduction has been 543 million tons of CO2 emission has been, million tons of emission has been reduced, and these numbers goes every year to the India's commitment in the Paris Agreement and even the other climate goals as well. Yeah. One of the interesting aspect of the program has been the compliance, where there are efficiency policies, but at the same time there is a focus and attention required on what has been the compliances checks as well. And for that, there are the three components under the standard labeling program. One is check testing. Basically, it is done by the Bureau of Energy Efficiency and state designated agencies as well. They go into the market, they randomly purchase the samples from the market and do the testing just to ensure are they complying to the declaration of the manufacturers or not. And I think the last year, the Bureau of Energy Efficiency done 300 plus samples testing. And this year they have a target of getting to almost 2000 samples to test by all the state designated agency, which are like 36 of them. I think that's been very promising and very aggressive to ensure the compliance rate is getting increased under the program. And there is another component of the checks, compliance check, which is challenge testing. It is basically the complaints received by the Bureau of Energy Efficiency. They do that challenge testing of that appliances, if there's any complaint received. And finally, it is about the market surveillance. And this is again done by the Bureau of Energy Efficiency and the state designated agencies, where the checks about the label accuracy and the correctness and the validity period of the labels which are there on the appliances sold in the market. I think one of the interesting aspect I want to spend 30 seconds here, where this activity started 3 years before, where class been supported on developing the overall framework. We did the pilot for this of 6,000 sample, and we able to design all of that to implement by the state government. And that has been further picked up by the Bureau of Energy Efficiency. And then successfully they completed 20,000 sample surveys last year as well with 32 states. And our team members like Momita Yada, they all been very much instrumental implementing all these market surveillance and check testing activities on overall program, I should say. Yeah. So that's about the compliance, and they want to even strengthen the compliance, I would say. Yeah. So coming to the last slide, I think this is the strategic plan by 2030. These are like majorly into 4 buckets. One is on the appliances. where the Bureau of Energy Efficiency wants to increase the appliance coverage from current 41 to 50 appliances by 2030 uh, to meet the climate goals. And also they want to make more appliances mandatory coverage, because mandatory gives more legal power and also ensures the energy efficiency norms are met and the market transformation takes place. The other aspect they want to focus is on the strengthening the compliances. Not only at the federal or the central level, they want to implement with collaboration with state governments, and they want to stringent that compliance checks also. And the third aspect is, as I said before, they want to align the Indian energy efficiency standards with global best maps for the key appliances, like which I already highlighted, the 10 major appliances, and they want to expand it to other as well. And finally, India has been like trying to play a leader role in the global south, and that has been well accepted in some of the countries as well, like in South Asian countries, the Bhutan, Nepal, Mauritius, and Maldives. They all want to harmonize their energy efficiency standards with India, and that practice is underway, and they already have formal MOU with Bhutan government, and they're also planning to expand it to the other countries as well. Yeah, so I think this is the overall strategy plan of the Bureau of Energy Efficiency by 2030. With on that, I'm going to pause and I'm going to stop. And yeah, over to you, Ed. Thank you.
Yeah, this is great. I want to thank all the presenters. I learned quite a bit. I'm sure other people did as well. Great presentations. I don't see any other questions on the chat function. Nazir's been posting certain things, but just information only. I will actually end with one question, then I'll hand it over to Nazir. And I'll make it general, but in the early days of MEPS and labeling and standards, manufacturers were resistant in the US. I was wondering, in India, for example, given all the different products you've mentioned, you don't have to name names of manufacturers, but are there certain appliances that manufacturers were resistant to compared to others, or are they now all on board and supportive of the labeling and standard scheme in India?
Yeah, sure, Ed. I think that's a great question. And I think that resistance was there in the inception of the programs, I think, but I think the manufacturers are now very well aware about the efficiency and also standard labeling program, and they're very much supportive on that. Uh, I think there has been a resistance in the last couple of years when there is efficiency improvement in the mandatory appliances, which are like trying to be global best. I think to meet the global best, they need to do a lots of investment, and also the technological constraint that's been a major challenges for them. I think the government trying to help them to address that, and also to promote the higher efficiency norms as well. And also we have seen a challenges for the industrial appliances manufacturer, like motors and the boilers, where those are like big tickets, and they need a huge investment to compliance to the energy efficiency norms. I think the government of India is also trying to support them, help them to come on board on the efficiency norms as well. Yeah, with different incentive programs. Yeah.
Great. That's very nice to hear. I'm going to hand it over to Nazir for closing remarks. Nazir?
Sure. Thanks, Ed. Thanks, everyone. Special thanks to our speakers from CLASP for the very insightful presentations and sharing the wonderful work that CLASP is doing in the energy efficiency space. I have put a couple of links in the chat. We would be really happy to get your feedback and opinions and suggestions for future webinars. Following discussion with our speakers, we will be sharing the slides if they're available, but of course we will be sharing the session notes. And recording of the webinar will be available on our YouTube channel. I have also put the link in the chat. That's all for today. Thank you everyone for joining us. Please follow us on LinkedIn page and website to know more about our upcoming activities. For now, we wish you all a good day, good evening. Thank you so much.
Thank you. Good night, all.
Thank you.
Thank you all. Thank you. Bye.
Thank you. Thank you.